Again, this is related to the empirical rule for normal distribution. It's just a slightly different set of percentages related to it. And so I'm going to try and sketch this out, solve it. So I'm going to draw my best bell-shaped curve. Oops, that's not a very good one. Let's try this. Oh, good enough. All right. So then here is going to be my mean. And for this problem here, they're telling me the distribution has a mean of 59. So we'll put 59 in the middle here. All right. So some information they give me. I'm going to use the one standard deviation first because I'm familiar with that one from the empirical rule. So if I go one standard deviation to the left, that'd be about right here. One to the right is going to be about right here. 68% of the data has to live in this range. A standard deviation in this case for my version is 9. So again, as far as counting standard deviations goes, that's a z-score. So the mean is a z-score of 0. A standard deviation of 1 here would be 59 plus 9, or 68. And one standard deviation to the left, which would be a z-score of -1, that's going to be 59 minus 9, or 50. And I know that in the empirical rule, 68% of the data lives from here to here. All right, adding on, so now I'm going to back up and I'm going to do this one right here. 50% mark. 50% of the data is within about 2/3 of a standard deviation. So if this is one standard deviation, this would be about 1/3, so that would be about 2/3 right there. So that would have a z-score of 2/3, -2/3 on that side, and 1/3, 2/3 of a standard deviation. It's going to give me a positive 2/3 over here. Okay, so 2/3 of a standard deviation is 9. 2/3 of 9 is 6. So that would be 59 plus 6 on one side, which is 65. And then 59 minus 6 on the other side. So that's going to be 53. So let's go back to blue. So this mark right here is about 2/3 of a standard deviation to the left, has a, let's see, we're counting babies here. So that would be 53 babies. And over here, 2/3 to the right, the 59 plus 6 or 65. And what do I know? Well, that between 53 and 65 is 50% of the population lives there. And then they give me the 95% rule, which is 2 standard deviations. So let's mark that one. So this is 1 standard deviation. 2 standard deviations would be about here-ish. So that's a z-score of 2. So these are z-scores down here. And 9 is a standard deviation, so 59 plus 9 is 68. 68 plus 9 is going to give us 77 on that side. And then if I go the other direction, 1 standard deviation, 2 standard deviations is maybe about right here. So that's a z-score of -2. And an actual value of 59 minus 9 is 50, minus another 9 would give me a score of 41. Right there. And then the 98% from the mean would be 2 1/3 standard deviations. So again, a standard deviation is 9. 2 1/3 groups of 9 would be what? 9 and 9 is 18, plus 1/3 of 9 is 3. That would be, I think, 21 on a good day. So that means 98% of the data should be within 21 of the mean of 59. So 2 1/3. So that's 2 standard deviations. So maybe 2 1/3 is about right here. 59 plus 21 is 80. So there's green. So that would be about 80, 2 1/3 standard deviations to the right. 2 1/3 standard deviations to the left, based on my scale, I'm guessing is about here. Negative 2 1/3. Which would be the z-score. Z-scores count standard deviations. 59 minus 21 would be 38. Is that right? Yeah. Okay. So that's all of this information right here put into a graph. I didn't write the percentages yet, though. I'll get to that in a minute. Now I want to try and answer the final question here. Let's see, what is the approximate percentage of days, oh, these were days, not babies, in which the number of babies born with a genetic marker numbers between 50 and 77. All right, so I identified where 50 is, that's right here. Let's get a highlighter out. And then 77 is over here. So then I need to figure out what percent is from here to here between those two lines. All right, so let's see, what do we got? 50 was related to 1 standard deviation. So within 1 standard deviation, we have 68% of the data total. Now I'm just going to look at half of that. And it's difficult. Get rid of it. So half of 68% should be between the mean and that lower -1 z-score there. So half of 68 tells me that about 34% of the data lives here. And I want to combine that with the other side from 59 up to the 77. Different color for that. So from here to there. So let's see, the 77 is 2 standard deviations. 2 standard deviations is 95%. So 95% would be all the way from this side to that side. I'm only looking at half of that. Half of 95 is what, 47.5? So this was basically a graphical problem to solve. So altogether, if I combine those, 47.5 plus 34, I get 81.5% of the babies had the genetic marker numbers between 50 and 77. So it was a puzzle based on the idea of a z-score and the percentages.